By touching the fox, the LED would be shining like the fox, and by touching it again, both of them would be turned off. This LED is connected to F7 Discovery Board via a 220 ohm resistor. The importance of this project is creating a graphical user interface and controlling an actuator like LED. It is important to know how to set up and write program for controlling LCD and touch sensor. Let's see how I did create this simple system together. This is one of my first experiments with GUI design using the STM32F7 Discovery Board and TouchGFX. I designed a simple touchscreen interface to control an LED. Let's check it out. To generate the code for this simple project, I used TouchGFX Designer software. When I launched this software, I was faced with a window like this. And when I wanted to create a new project, I was faced with these options. And I tried STM32F7 Discovery Board and I selected it. I chose a name for this project and a location to save the project. Then the project was ready to be created. Then I was faced with such a window. I created a toggle button here. You can find it in this panel. Here is toggle button, and here you can set the properties of this toggle button. It is automatically called toggle button 1. You can change it if interested. Then I select images for this button, once when it is released and once it is pressed. For the time that it is released, I set the picture to be a dark sly fox, and when the image was pressed, I set the picture to be a shining sly fox. The important thing to note here is that the resolution of these pictures are 480 by 272. That's because the resolution of the LCD, which is mounted on STM32F7 Discovery Board, is 480 by 272 pixels. You need to add these images to your project by this button before being able to use them. And after setting images for my toggle button, I went to interactions, and by use of this button, I added an interaction. I set the trigger to button is clicked. I left it as what it is. I set the action to call new virtual function, and I called it toggle LED. After doing it, the code was ready to be generated. I generated the code using this button, and once the code was generated, I selected files. I was in TouchGFX folder. I went to project folder, STM32 CubeIDE, and I selected this project file. After that, TouchGFX generator has created these codes by the use of CubeMX for you. To be able to open main.c file, you can find it in user, core, main.c. But first, I need to set some settings in our CubeMX file. To be honest, everything was automatically set by the use of TouchGFX code generator, I mean LTDC, Quad SPI, FMC, and everything that was related to external flash, LCD, and touch sensor. What I did was setting pin PG7 to GPIO output, and I labeled it as LED. Then my CubeMX was ready to generate my code. When the code was generated, I didn't do anything in main.c file, but in application user GUI, there is a CPP file called screen1view. I needed to open it, and here is its header file. I need to declare a function here, and the function had to be virtual, so I created this function and called it toggle LED. In a screen1view CPP file, I included main.h to be able to access my GPIO labels and HAL library. And here I declared the function body. And this is how it works. I told the MCU to check the state of the toggle button. If the toggle button was pressed, then it had to set the LED to 1, which means turn it on. Otherwise, if toggle button was released, reset the LED to 0, which means turn it off. It was the only code necessary for this simple project, and our code is ready to be built and uploaded on our microcontroller. Before uploading the code to our microcontroller, we need to prepare the circuit and hardware. To do that, pin D4 of the Discovery Board must be connected to anode of the LED. This is done via the red jumper wire, which is shown in the picture, and the GND pin of the Discovery Board must be connected to cathode of the LED. It is done via a black jumper wire, which is shown in the picture. As you can see in this picture, the red jumper wire is connected to anode of the LED, and the black jumper wire, which is connected to GND, is connected to cathode of the LED via a 220 ohm resistor to control the current overflow through the LED. And here is the final result of this project. The source code and all project files are available in my GitHub repository, and the link is available in the comment section below. If this video was helpful for you, don't forget to like it and subscribe to our YouTube channel for more videos. Good luck!